Hello, my name is Tristan and we're going to be going through chapter 1.1 of Physics A2. I'm going to be using this book for questions and information. And if you're doing a different exam board to AQA, then this might not be the video for you. Now, we're going to do momentum. And we know that momentum is equal to mass multiplied by velocity. Now, to find the units of momentum, we take the units of mass and multiply them by the units of velocity. Nice and easy. Momentum can be changed when a force is applied which is big enough to overcome friction. Now, with friction, let's imagine we have a table, a very well drawn table. We have a person exerting a force on this table to try and push it over there. Now at rest, the momentum of the table is 0. Why? Because its mass, let's say 15 kilograms, multiplied by its velocity at rest, which will be 0, will equal 0. But if this person here pushes with enough force to move the table, 15 kilograms will now have a velocity. So let's say he pushes it 2 meters per second. His momentum will now equal 30 kilogram meters per second. That is the table's momentum when it is being pushed at this velocity. Now, to calculate the force, or resultant force, using momentum, we can take Newton's second law, that the rate of change of momentum is proportional to the resultant force. So resultant force is proportional to the rate of change in momentum over time. Now when we hear the words rate, we always want to think divided by time. It makes it a lot easier later on. Now, when we have a proportionality sign, what we want to do is get rid of it. It's nasty, we don't want it. So, we know if we want to get rid of a proportionality sign, we add a constant. So F, or force, will be equal to a constant multiplied by change in momentum over time. Now, to get rid of this constant and make it even easier, we always assume that the constant is equal to 1. This gets rid of this constant. So we end up with force is equal to change in momentum over time. Now, how do we get change in momentum? Well, the change in momentum of an object is equal to its initial momentum, which we will call mu, minus its final momentum, let's call it mv. Now, once we have this, we can enter it into this formula here. So F will be equal to mu minus mv divided by time. Now, let's imagine that velocity is constant here, or is the same. We would end up with F is equal to mv minus mv over time. But it's not actually written like this, because momentum will build up. So what it will actually look like is this, and mv minus mv will actually reinforce. So we will end up with, to simplify, F is equal to m multiplied by v, or change in v, divided by change in time. Now, an example of mass staying constant is the majority of things. So the table again. If it's being pushed this way, its mass is constant. But if we had a constant velocity, we would write it like F is equal to V, change in mass, divided by time, or change in time. Now an example of this would be a rocket. Not a particularly artistic drawing, but a rocket. When it goes up into the sky, or into space, it's burning fuel, so its mass is decreasing. Now, let's move on to impulses. They're very similar to momentum. What we have with an impulse is the time taken multiplied by the force. Now this happens to also be equal to the momentum, or change in momentum. Because if we rearrange this formula, we end up with, we times the time up to here, so we get time times force is equal to change in momentum. Now, this is an impulse, this is momentum. Now, let's look at some questions. Hopefully, I can edit the video and get the questions on the screen while I do them, but you never know. So, we're going to go in this book, I'm going to go to chapter 1.1, and we're going to do the summary questions. These ones. Now, the first question, which should be on the video, let's hope. Is to calculate the momentum of an atom of mass 4 times 10 to the minus 27 kilograms moving at a velocity of 3 times 10 to the power of 6 meters per second. Now, using our formula, we know that 4, or the mass, will be multiplied by 3 meters per second, kilograms. Right, now we have these two numbers. Now what we need to do is multiply them together. Easy peasy. So we will get, or you should get, 1.2 times 10 to the power of minus 18 kg meters per second minus 1. Nice and simple. Now, let's move on to something slightly more tricky. Okay, let's do question 3. An aircraft of total mass 45,000 kilograms accelerates on a runway from rest to a velocity of 120 meters per second. When it takes off, during this time, its engines provide a constant driving force of 120 kilonewtons. Now, what we should do when we get a question like this is to write down all the facts it's given us. So we know the plane weighs 45,000 kilograms, it has a velocity of 120 meters per second, and a force of 120,000 newtons. We want to get rid of the kilonewtons. So those are the 3 things we're given. Now, in part A, it asks us to calculate the gain of momentum of the aircraft. Now, to find gain of momentum, we take our formula for change in momentum. So let's say we have mass, which is remaining constant here, and the speed or velocity is also remaining constant, because let's say our starting velocity is 0, which it is because it's not taken off yet. And we're going to be taking this away from 120. So these are our change in V. So overall, our change in momentum is going to be the mass multiplied by our change in V, which will just be 120. And this should give us 5.4 times 10 to the 6 kilogram meters per second. So that is the gain in momentum of the aircraft. Now, part B asks us to find the takeoff time. Now, we know force, and we know that it's equal to the change in momentum, which we've worked out here. So, change in P, and we're looking for T. Now, to find T, we're going to have to rearrange this formula. So, to get rid of the T, or get it on its own, it's going to be T is equal to change in momentum over force. Now, this is because we divide F to get it over here, and we multiply by T to get it over here. Now with this formula, we can find that 5.4 times 10 to the power of 6 divided by the force given, 120,000 newtons, and this will be in kilogram meters per second, will give us an answer of 45 seconds. Now, that will be our answer. Nice and easy. This will be the first video. I think I've covered what you would have learnt from that part quite well. Please like, subscribe, I guess. I'll do more of these, hopefully, and we'll all get A's together.